games with authentic battle damage. So we're going to start out today by creating a rock, paper, scissors game. And we're going to be focusing on statements to start out. So let's take a look at this. So this is Zemarian, and we're going to start our console project. So I went up and did File, New, Solution, and we'll do console next, and we're going to call it Rock, Paper, Scissors. And this is what we get. So if we run this, you'll see that it prints out on the command line, hello world. Now, if I'm on Mac, so it does this for me, but if you're on Windows, you're going to need to type console.read line. And what this will do is make sure that it pauses it right here so that the window doesn't go away. And then you hit enter, and then it will complete. So just remember that on Windows, if your window pops up and then disappears, you need to add a read line, because this will read in whatever you type on the keyboard. It'll be kind of like a press any key. But we're going to strip this down now. We're going to be talking about statements. So first of all, I want to get rid of this namespace because we're not going to be talking about namespaces. We're going to talk about classes when we actually create a class. So this is our main class, but we're going to rename it Rock, Paper, Scissors. So statements, we can't really talk about statements without talking about variables. So we'll talk about those as well. There are a bunch of different variable types. There are integer, there's floats, and what we're doing here is we're defining a type, and then we're giving it a name. We can call it whatever we want. We can call it int, whatever we want. And the naming of these are very important because it gives us a hint as to what we intend to do with it. So for example, let's say we're writing a program to balance our budget. Let's say we have a budget. And say we have int budget. So this integer represents our budget. So we can then assign 100 to it. Let's say our budget's 100, and then let's say we want to increase our budget. So we would create a statement, and a statement would look like this. We would take our budget, because at this point the program starts here on line 8, and the value 100 gets put into budget. So now budget equals 100. And we can see that if we do a console.write line. So what this write line statement does is write line here is a method, just like this method, but it's a method on this object or this class, the console class. I'm going to be going over these things many times, so this won't be the last time I talk about this. But in console, you might be wondering, well, where does that come from? How do you know to use that? Well, console exists in this library system, and I can prove that by doing this. I can go system, because this is our library, dot, and then here it shows you all of the things that are in system, all the things that we can call from system. And console is one of them. Dot write. So write will write without a new line, and write line will give you a new line on the console. So it'll take the cursor down to the next place. Okay, so yeah, so console is a class, just like this class. Everything is made up of classes, okay? Everything in C# is a class. In a console program, all we really care about is main, really. We don't care about this class at all. Classes are used as a way of representing things for us in our program. You know, whenever you make a program, you're trying to model something. You're trying to create something that represents something else. That's exactly what, we're doing in games. We will create classes that represent the player, or classes that represent, an enemy. So, all right. So we got our class console. It has a function called WriteLine. And let's hover over that for a second. And you see it says public static void WriteLine. And the return value, it takes in a string. And that's what we're doing here. This is our string. And to concatenate strings, you use a plus sign. Some programming languages use a dot, and some use a plus. C# uses a plus. Now, when we put budget here, it will create a complete string that says budget now equals, and then it'll have our number, the number that was put in here, because this is a variable that represents this. Okay? So let's play this. Now, I think I've told you this before. Budget now equals 100. Yeah, that's exactly what we wanted. I love errors, and I'm going to get a whole bunch of errors when I'm doing these. And I'm doing that on purpose. Sometimes not on purpose. Sometimes it's on accident. But I'm doing it on purpose because one of the things I feel like people don't get to see is when things go wrong. And when you're programming, things go wrong a lot. You have a lot of things that you have to keep in your head. And it's very difficult to do. So sometimes you're going to get an error, and how well you can read an error and correct an error is going to contribute to how successful you can be as a programmer. So, all right, so now let me show you a statement. This is basically where we're assigning the value to budget. And now let's say we want to increase the budget. So what we do is we would say budget equals our budget plus 50. So this is obviously we're adding 50 to the value of budget. And we're going to prove that by saying that budget now has been increased to budget now has been increased to 150. So you see how things execute is important. There is what's called an order of operations. And when you look at statements, you want to understand the order of operations that occurs. So, for example, think about it this way. To the right of the equal sign, this becomes this. And then this becomes this. Does that make sense? So like, that's how you should think about it, like in your head, that, so let's say, for example, we did something like this, times 2. Now, the computer, this is one of the very important principles. Computers do exactly what you tell them to do. They have strict rules for how they operate on things, okay? So one of the things is the order of operations. So multiplication always happens before addition. So it's going to always happen, like, let's do this too. Let's say we divide by 5. I don't know. Let's say we divide by 5. This will happen first, then this, then this. And let's confirm that. Okay, so we can confirm it by just doing a search for order of operations. So you can see here, left to right. So here what they're showing is what we're showing here is a brace, and then parentheses. Whatever you wrap in parentheses will be done first. So, and then we've got dot, pointer, plus plus, minus minus. And it's showing you that, for example, typecasts, these are the order that it decides to do things in. So you can see here multiplication, division, and then this is the modulus. This basically creates the remainder between two numbers that are divided. Plus, then minus, and it says here 2 left to right. So if you have several of these, it'll do them left to right first, and then bitwise. Bitwise shift, and then relational, and so on and so forth. So you can always look at these. These are important to understand because there is an order that these things happen in. But I can force the order if I do this, for example. Now what I'm saying is, because I put these in parentheses, I'm saying add this first before you multiply it. So let me show you this. If I don't have the parentheses, let's look at what the answer is going to be. 200, which makes sense, right? Because 500 times 2 is 100 plus 100, because that's what's in our budget right now, equals 200. So now, if I put parentheses around our addition, you're going to see we're going to get a different answer. Now the budget's been increased to 300 because budget 100 plus 50 is 150 times 2 is 300. So order of operations is something important to understand, and I recommend just doing a search on order of operations in C#. I recommend doing a search for order of operations in C#, and you'll be able to see what things happen first. But it's really important when writing and reading your code. So these are statements, and there's many different types of statements, but these are the first ones we're going to cover. So if you enjoyed this, please subscribe and comment if you have any questions. Also, I'm looking for Still, any ideas? We're going to be working on these games. We're starting out with rock, paper, scissors, and we're talking about statements right now. We've covered a little bit. We just touched on where we mentioned namespaces, and we talked about methods a little bit. We talked about classes. We're going to go into those into more depth, but take a look at these games, and in the comments, still let me know which ones interest you the most. Which ones are you most excited about us working on? Now, I know we're making a rock, paper, scissors on a console, but I really wanted to separate the C# programming language from Unity. We're going to be talking about a lot of specific Unity stuff, but not right now. So, anyway, thanks for watching.